Thank you very much to everybody. I'm Marco Fonnesu, and I'm a sedimentologist and explorationist for ENI. I want to say that it's a great pleasure to be here. I thank you a lot, the organizer, but also I want to thank a lot my former supervisor and collaborator from my PhD. I mean, Peter Auton, William McCaffrey, Fabrizio Felletti, Marco Patacci, and the whole Turbident research group, because this work is actually part of my PhD work, and that I finished about 4 years ago. The time flying very quickly. So now I will give you like a spot of my work, also a bit more on perspective, like the kind of concept I matured through times and how I look the hybrid peb embed now after the experience that I grow in the industry. So to start, I would really like to go back to the basic, like to really highlight what are the things that matter for industry into all this hybrid have and bad concept. Like everybody knows that the conventional gravity flow have a general phase tract that predict that we have poor quality phases in terms of debris developed mostly on the slope, like in side channels or in the area where they deposit more closely to the area of source, and then the sandy part of the flow is able to bypass and deposit the high density and low density part of the flow itself with the good part, the reservoir part of the lobe. And then with this process, the mud is efficiently segregated into the mud cap. So we have a very good separation between the sand at the base of the bend and the mud usually accumulated on top by the turbulent cloud. Otherwise, the flow can interact more intensely in the substrate and train a large quantity of muddy materials that remain locked into the flow, and so by different kind of process can develop what Peter in 2003 called linked debris, and then now have different names and some many types of characteristics, but what is important that we have a central and distal part of our lobes that may have a very poor quality sandstone. So let's do like a simple exploration game. Imagine we have a prospect on a side of structures and we drill our exploration well. We got lucky and we found hydrocarbon in a Gauss-Town 2 situation, for example, but we got quite disappointed after looking our logs about our reservoir quality. Then we can apply maybe two different models. We have the first models, like we will be in a kind of debris flow, turbident flow model, and maybe we just hit the part in which the debris flow didn't really pass through and evolve into the turbidic current down deep. Or the other option would be we have a series of stacked hybrid heaven beds, and our low quality is derived by this kind of model. When our manager will ask to drill our appraisal well to test the potential hydrocarbon water contact, we can have two options, maybe go more proximal or more distal. But depends on the model we're gonna apply by the limited data that we have. Imagine we don't have core at that time. We have to make the decision of this kind. And for example, if we apply the first model, going more proximal will be a mistake because we found even a worse reservoir, and maybe the project will be abandoned. Otherwise, we go distal, maybe we not get the best reservoir ever, but if the structure is large enough, it will be still economically viable. Otherwise, if we are in a hybrid heaven bed context, for example, going proximal, we can find maybe an excellent reservoir. Otherwise, going distal would be a big mistake. So this look really simple. Maybe all of you are really aware of these kinds of problems, but those are the simple models, the driving decision in industry. And you understood from the presentation from today that this is not so simple. Every bed are becoming more and more complex. And we see you, I will try to show you why. During my research effort, during my PhD, I tried to look at hybrid bed and the entire problem in a kind of very wide way, always with a kind of outcrop and fieldwork approach, but looking at different scale the problem. For example, I spent quite a lot of time characterizing phases and trying to develop a bed classification scheme that was mostly based on the texture of the H3 division, which I think was the real hint for detecting the kind of flow process and proximality and distality of the system itself, also from the kind of evolution of that the bed will have. Also, I try to correlate beds in long and short distance to explore facial structure and infer from process. I look at the system at larger scale to see what could be the area of highest distribution of hybrid bed, how they are stacked vertically. Also, I try to upscale on the general control factor, trying to distinguish between allogenic and autogenic control. So I have to say it was particularly hard to me to select a particular aspect in which to focus just a short talk like this. But I think an overlooked topic at the time, but that got much attention nowadays, is the role and effect of substrate entrainment. I mean, not looking only at the hybrid bed deposit, but also the flow and what happened just before. To do so, I will bring you in north of Italy at the beautiful exposure of Monte Ramaceto, where the confined basin plane of the Gottero sandstone crop out. Here is myself with my jack of staff, very proud after logging one of their several sections over there in a succession that is over 1,000 meters thick. The area is particularly amazing because you can individually trace each of these beds in the length of the outcrop for over 4 kilometers. And not only, the succession is completely upside down, being in a reverse limbo regional syncline. This meaning that these beds expose very well their base, and they're exposed in very extensive deep slope. And this is one of these deep slopes found just underneath one of these hybrid bed, and here exposed for over 170 meters. If you look at that, we see that it's fully ornamented by a series of scour features. And if we look that in details, we see that these scour features have a kind of very particular tiring structure with grooves that predate two steps of scours. If you look at these scours in detail, we see that these are not really full erosional features, but we see mud clasts in the act to be detached from the substrate. And another interesting fact, if we see these scours fell apart, we see a kind of lineation fabric orthogonal to the paleoflow direction. This means these are not actually erosional scours, but are more like seal-like injections. Similar features can be displayed even at larger scale. On the left, there are some correlated beds on the exposure of the Monte Ramaceto for extend for hundreds of meters that showing removal of meters of succession underneath in a completely flat way that you can understand only if you correlate these beds for a long distance. And this is a close-up of one of these beds. This actually come from another exposure still from the Gottero, and you see very nicely how the base of the bed looks flat for tens of meters and then step up quickly. And this is actually a piece of stratigraphy completely intact. Underneath there is an injection, like this was a part of the substrate in the act to be removed, but where actually the removement of the flow didn't really work. So this means that this event was able to remove at least 1 meter, 1.5 meters of succession completely undetected. And where all this mud where are now probably will be trapped into the H3 division, maybe some 10 or 100 meters down deep. These features are not unique from the Gottero, but they are really commonplace in many deep water succession, especially associated with cluster-rich hybrid bed. This flow bed interaction should have by intrusion and delamination of core and piece of substrate and doesn't imply bypass. The mechanism is able to produce these large tabular scours, and are particularly common on basin floor or against topographic high. It was very nicely depicted by Prudek Fagrebas et al. In the Unknown Sandstone. This is, of course, not the only mechanism of erosion existing, of the entrainment existing, but substrate entrainment can be linked also to more conventional turbulent erosion features formed by effect of mechanical abrasion of the substrate by a turbulent flow. And this produces more convex downward scours, developed as a cut-field features, or mega float type of features that are more common in channel lobe transition, and base of flow settings. And these kinds of interaction otherwise imply inconsistent sediment bypass. So meanwhile, delamination features seem to be linked to very high dense flow, able to apply differential pressure on the seafloor and somehow intrudes and detach large piece of glass or even raft. The turbulent erosion is able to provide only small chips and consolidated clay to the flow. So in my view, the way of flow interaction is the direct correspondent to the type of flow and deposit, we're gonna find just down deep, like down deep to this kind of delamination features and this strong kind of interaction and remobilization substrate. Probably we'll have more kind of immature bed with mud raft, sometimes still keep it there. Sometimes can be even 20-meter large, the single raft, like they are huge. They are huge depending on the size of the scours which are correlated, or more maclast rich. Otherwise, where turbulent erosion is involved, you have more kind of evolve type of hybrid bed, and you form more this kind of argillaceous type, which I call, for example, HEB5. Controls on these two type of behavior are for sure the flow density, but also the mechanical properties of the substrate. Like a firmer substrate would be harder to erode by smaller flow, but would be able to entrain large quantity of mud and clast all together. Otherwise, a soft substrate will provide easily breakable clay bonds that will vary quickly and dump the turbulence very well. And a step forward in this direction was taken by Patacci et al. In their work, they measured the mud cap of hybrid bed and turbidite bed. What they've seen is that the mud cap of the turbidite bed is much thicker than the mud cap of conventional of the hybrid bed. Also considering the mud trapped into the H3 division, like there was really on another kind of direction. And also they understood that the mud cap and clast from the H3 and from the mud cap mostly derive from the basin substrate. This means that the mud entrainment versus fractionation rate should be a key control on the clay concentration in the basal layer of the flow, and therefore on the likelihood or rheological transformation from turbidity current to hybrid flow. Turbidites may have a more continuous kind of erosion interaction of the substrate, have more elutriation kind of efficient process, and the mud is segregated efficiently in the mud cap. Otherwise, hybrid bed have less efficient process. They delaminate, they get mud all together very quickly, and it remain and they develop thinner mud cap. So, in conclusion, my feeling is that also after seeing all this presentation is that the increase in knowledge in hybrid bed process are actually decreasing their predictability. I don't want to be critical. I don't want to mean that knowledge is bad. Actually, there's not. We know more the limits of our models, but the positional models are becoming more and more complex, predicting hybrid bed not only in the lobe fringe, but in a large spectrum of sub-environment. Also, the controlling factor as individual flow density and rheology are controlling factors that are not controllable in terms of prediction in reservoir exploration scenarios. So we have still no clue about the true risk assessment in hybrid bed present chance, and answer to the simple exploration game I was showing you before is not so easy, because there are so many control factors that maybe we'll have a completely different geometry scenarios by scenarios. So my advice to proceed in the future to keep the hybrid beds a trend topic in research, it will try to, now we have almost all the elements, and to try to have a more kind of comprehensive, maybe database approach, to able to discriminate what are the most probable controlling factor and fetch schemes. Like come back to predictive models in order to answer to the final question is why some basins are so full of hybrid bed and some others lack to them completely. So thank you very much for your attention. I leave you with a beautiful image from the gutter sense and those hybrid beds. Thank you very much.